So welcome back to another video on fast Fourier transform. So the question is perform the 4-point DFT using DIT algorithm. So DIT algorithm comes under the fast Fourier transform for the following function x of n is equal to 8480. Okay, for this one since it is x of n value, so I have to perform DFT. So here it's 0 value is nothing but 8 and 1 value is 4, 2 values 8 and 3 values 0. So how to represent 0 in 2-bit? It is 0 0. So 2 is 1 is 0 1 and 2 is 1 0 and 3 is 1 1. So first step is you have to bit reverse this one. So if I if I change the position, you will get again 0 0. So if I change this position, you will get 1 0. If I change this position, I will get um, 0 1, and if I change this value, you will get 1 1. So you have to substitute now 8 8 4 0 in the DLT algorithm. Okay, so you have to substitute like this. Okay, first let us draw the 4-point DIT algorithm diagram, butterfly diagram. So this is how you have to draw the diagram. So first you have to substitute 8840, right? So instead of 8480, you have to substitute 8840 after applying the reversal, bit reversal value. Okay. So after that one, what you have to do, you have to add these two values. So if I add these two values, I will get 16. So if I subtract these two values, I will get 0. So if I add this value, I will get 4. If I subtract 4 minus 0, I will get 4. Okay. So after that, this is how you have to draw the, this is a diagram, another diagram. So you have to add 16 plus 4. 16 plus 4 is 20. Then 0 plus 4 is 4. And you have to multiply here. Here you have to multiply 4 minus j. Okay. So it is nothing but 0 minus 4j. You will get minus 4j. 4j or 4i. Okay. So here you can see at the base you will have minus 1. So here you have minus 1, here you have minus 1. So here also you have minus 1, here also you have minus 1. So in order to find this value, okay, so you have to subtract 16 minus 4. 16 minus 4 is nothing but 12. Okay, so you have 0 minus, okay, 0 minus 4i. So you will get 4i. Okay, so after getting this value, you have to, so the only change we are having here is you have to add minus j here. Okay, so it is not 4 here, it is nothing but minus 4i at this point. Okay, so similarly we can do it for, so first let me draw the diagram. So since all the values are 1, even if you take the bit reversal value, you will get the answer is 1, right? So first let me draw this one. 1 1 1 1. So here it is minus 1. Sorry, this is how my diagram is, right? So this is my diagram. 1 1 1 1, right? So this is x of n value. So you will get capital X of n value here, okay? Capital X of k value here. So after applying the bit reversal value, since all the values are 1, even if you change the bit, you will get set as 1 only. So you just add this value, you will get 2. If you add this 2 value, you will get 2. Suppose if you subtract these 2 value, you will get 0. Subtract this value, you will get 0. Okay. So here you have to multiply minus I. So 0 into minus I is 0. Again you have to add these two values, 2 and 2. you will get 4, 2 and 2, right? Then 0 plus 0, you will get 0. Then 2 minus 2 is 0. 2, yeah, minus 0 is 2. Phew. Let us take another problem. X of n is equal to 1, 0, 0, 0. So here also if you reverse the value, you will get 0, 0 only. Okay. So now let me do the DIT algorithm. So if you add this one, you will get 1. If you add this one, you will get 0. If I subtract this one, I will get 1. If I subtract this one, I will get 0. Okay. Again, you have to add these 1 and 0. Right? If I add 1 and 0, I will get 1. If I add 1 and 0, I will get 1. Okay. Then you have to subtract 1 minus 0. 1 minus 0 is 1. Right? Next, 1 minus 0 is 1. So the x of k value is equal to 1, 1, 1, 1. So this is as simple as what you are expecting. Right? So next, 1 minus 1, 1 minus 1. Okay, this is a question. They're asked to find uh, x of k, okay, using DIT algorithm. Okay, so this is x of 0. Now instead of 1, you have to substitute in 2. Okay, after bit reversal. So this is 1, 0 becomes 0, 1 now, and 3 is minus 1. Now if I add this one, I will get 2. If I subtract this one, I will get 0. If I add this one, I will get minus 2. Minus 1 plus 1. Minus 1 plus 1 is 0. Okay. Again, if I add these two value, I will get 0. Again, if I add this two value, I will get 0. Right? Then 2 minus 2. That is, answer is 4. Right? Then 0 of 0 is 0. So answer is 0, 0, 4, 0. So you can verify this equation using the normal method, right? So the question is x of n is equal to 1 minus 1, 1 and minus 1, right? 1 minus 1, 1 minus 1. So the answer is, so the answer of x of k is equal to 0, 0, 4, 0. So this is your answer. So let us now try this problem. Try to solve using that circle method, right? So if I add this value, I'll get 0. So x of k, here it is 0, right? X of 0 value is 0. Then x of 1. X of 1 value is nothing but 1. You have to multiply minus j, you will get plus j minus 1. Minus j, it is j. Minus j, sorry. So you will get answer as 0. Next, x of 2. Capital X of 2. So 1 minus 1, if you substitute, you will get 1 minus 1. 1 minus 1, 1 minus 1. So you will get answer as 4. Sorry. Next, 1. If you leave the two values, you will get minus j, minus 1, minus of minus j is plus j. So you get answer is 0. Okay. So this is how you have to verify the answer. So answer is 0, 0, 4, 0.